Hey everybody, how are we all doing? Let me know if there's any issues. Looks like everything's working. I just had to put a massive cardigan on because it's getting really cold in Scotland. Cold and dark. Okay, let's bring Cedric into the stream. Hey Cedric, how are you?
Hey, good evening. All good?
Good. How are you feeling for a Monday?
Pretty good. It's the end of Monday, so the worst is past, right?
Exactly. And now you have a fun hour of teaching serverless. What more could you
Exactly.
want from your
Talking
Monday?
about awesome technology. I mean, that's a good ending of my Monday any day.
Exactly. I actually thought that today was Tuesday. So that's how my Monday started. I spent the first half of the day thinking that it was Tuesday. But I love doing these streams on a Monday. It's a different way to kick off the week. I like doing something different on a Monday. I think it sets the tone for the week.
Yeah, and you still kind of have battery charge left, right, after the weekend. It was a tough Monday for many people, but you still have some battery charge left to learn new things, and I think it's a great moment to do these type of events on a Monday evening for us, or during lunch break or whenever you're attending.
Yeah, absolutely. Absolutely. I'm just going to just double check a few things. Okay, let's bring in the slide and let's see if I can actually remember to talk about the slide for this series before just handing it off to you. So,
Right.
if you've been here before, you know the drill. If you're new, welcome. Please take a second to either scan the QR code that you see in front of you or go to the link that you see on screen, and I will put that in the comments right now. Let's just make sure I give you the correct link. If you could take a moment to do this, we'd really, really appreciate it. First of all, you get free Microsoft Learning materials relevant to this series. So, why would you not? But it also really helps the Cloud Launch and Learn team because Microsoft are our sponsors, and it's good to see who's viewing and who's interacting with our session. So we'd really appreciate it, and you get some free learning materials out of it as well. So I'm going to post a link in the comments so that you can grab it there, or use your camera and scan the QR code and it will jump up. I feel like everyone's become more accustomed to QR codes these days because of track and trace. So anytime you go to, for instance, in Scotland, anytime you go to like a restaurant or a coffee shop, quite a lot of them are using QR codes to bring up the track and trace form and filling it in. It's funny, I hadn't seen QR codes in a while and they've made a comeback. Not in the best way, but there we go. So we are 1 minute past 6. I'm just going to double check that everything is definitely good to go, and then we'll hand over to Cedric for the first in our serverless series, which I'm really excited about.
Right.
Okay. Yes, I think we're good. We'll bring this slide back at the end if you missed it, and you can grab it in the comments. But I'm going to leave you now and hand you over to Cedric and enjoy the session. If you have any questions for Cedric, pop them in the comments and we can get to them at the end. Cedric, would you rather?
Yeah, in the end. Let's do in the end because I won't be able to see the questions, but we'll definitely. I'll leave some room for questions at the end.
Okay, awesome. Let's do that. Okay, have a great session.
Thank you.
Bye-bye.
All right. Thanks, Lisa. Cool. Good day, everyone. Good evening or good afternoon to from wherever you're watching. I'm Cedric. I'm a cloud solutions architect with Microsoft and an advanced cloud expert for serverless and containers. So in my day-to-day job, I advise our customers on how to leverage cloud technology and mainly how to leverage serverless technology and containers. Now I put here a little hashtag CLL serverless. Feel free to use that hashtag throughout the session, as we will come back to that later on in one of the demos. We'll do some magic with that on some LogicApps and see how that works. So feel free to tweet a bit about what you think about the session so far, and maybe you'll see your tweet pop up in the demo later on when we're there. So we're doing this in a 4-piece session for now. Today's goal is to kind of set the stage for the next 3 sessions, right? Today, what I want to do, it might be a little less technical than what we'll do next week and the weeks after. What I want to make sure that I impart on you today is to give you a good understanding of what do we mean when we say, let's go serverless, let's go cloud native serverless, and that kind of stuff, right? What does it mean to be serverless? Right, and to get there, we need to kind of look at the evolution of the application platform, where it all started with the good old days on premise, which I think most of us will still remember, or are still working today in an on-premise environment, and then have that evolution that many of us went through or are going through IaaS, PaaS, and then finally landing on serverless. So when we talk about the times before cloud, what do we actually mean, right? When developing an application before cloud, when you're just using VMs on premise with hardware, there's a lot of questions you need to ask yourself as a IT team, developers and operations people together, on how to handle that workload, right? How are you going to cool the racks? How are you going to set up your networking? How are you going to do scaling? How are you going to patch management? I mean, the horror of, I think, every single operations person is like, okay, developer says there is no downtime allowed. When are we going to do patches? Not at all then, I guess. So there's a lot of, it's quite a struggle. Like it's hard to do very well in an on-premise environment, and there's a lot of questions. When we moved to the cloud, we got access to infrastructure as a service, right? Many of you will be there today or will be leveraging various parts of IaaS services, and it made things a little bit easier, right? You no longer have to worry about a lot of the plumbing. How do you do physical networking? No more wires. Some of the patch management has disappeared, right? No more finicky storage clusters that need to be updated or patched. No more physical servers that you need to fix and set up. All that is gone, but you do still have a bunch of questions on how to right size your servers, still on how to scale, how to cluster. As we all probably know, clustering brings a whole bunch of other trouble with itself and complexity. Where there's complexity, there's a bigger margin for error, and we see that with clustering, it is difficult to set up, right? From a deployment point of view, still kind of difficult because we're still using VMs. How do I get a consistent deployment going on? A lot of scripting often to get that right, and still a error-prone process. So then we went to PaaS, or then a lot of us go to PaaS, where again, part of the complexity is abstracted away, and you no longer have to think about your VMs and clustering. You still have to think a bit about how are we going to scale, what kind of SKUs are we going to use. But again, a lot of complexity from an operations point of view has been abstracted away for you. So no longer patch management and that kind of stuff. That's all done behind the scenes as a service for you as an end user. Now, the last step in that evolution, if you wish, or how at least I would dream it to be, is to go truly serverless, where the question is no longer, oh, how big should my server be? That is irrelevant at this point in time. You just need to know, how is my application going to look like? Scaling, patch management, and all that is no longer an issue or no longer something you need to think about. You just need to think about, how am I going to process my inputs and outputs? How am I going to connect everything together? How am I going to architect an application? Scaling, patching, and everything below, all the plumbing is done for you. You just get a unit that automatically scales out, up, and whatever you want, has built-in monitoring, has built-in all the tools that you or that your operations team might need, or as a developer you might need for troubleshooting, all built in nicely there. So what is serverless? Well, it's an abstraction of servers. There is still servers, of course, but you just don't see them anymore. They're maintained for you. You just focus on your code. It is nearly instant, right? Instant doesn't really exist yet, but it's nearly instant, and it's event-driven scalability. So you no longer scale with full-on VMs. You just scale on depending on the need and the amount of requests you're getting. And one of the coolest things that maybe as technology people we don't care much about often is the pricing. Serverless is the most efficient way, financially speaking, and often compute speaking as well, to leverage compute in a cloud, right? When your scale unit is a VM, or your scale unit is a function, the price difference is huge. Plus, with the function, if you're not triggering that function, you're not paying for it. If you're not triggering that logic app, you're not paying for it. If that Docker container is not running on your ACI, you're not paying for it. With a VM, the moment you turn it on, you're paying for that VM. And the scale of your billing with serverless technologies is much lower. So what components do we generally speaking talk about serverless? Because it can be a lot, right? We nowadays also talk about serverless SQL Server, all kinds of serverless other services. But when we talk serverless and application development from an application platform point of view, we talk about functions, logic apps, and event grids. Right, with the major difference between functions and logic apps being that logic apps gives you that virtual designer, is more oriented probably towards enterprise integration, where functions is more a play garden for your developers, being trigger based with bindings. I'll go a bit deeper in each of these in a second. Now, within that platform of serverless, you're going to leverage technologies like a database, and you can recognize probably the logo of a Cosmos DB, but also you can do stream analytics or various cognitive services that you can easily trigger from these functions, logic apps, or connect with event grids, allowing you to build that entire ecosystem for your platform, for your application. Now, no application can be built without some good tools. So you do need that support from a development point of view, where from an IDE, and that's something we'll briefly demonstrate later on, you can just create and deploy your functions. It's integrated full on with GitHub Actions or Azure DevOps pipelines or any other DevOps tool you would like to use for that matter. You can full on locally develop, right? It's not because you're developing for an Azure function that that development has to happen in Azure natively. You can do that locally, emulate some of the services you might use, and run that, and comes in with built-in monitoring and all the jazz that you would like to see. So we have an overview here of some of the platform functionality, some of the components. Now, how does a sample serverless application, how does that look like, right? Often it doesn't look much different from what you would expect a normal application looks like. So I got here a couple examples, 4 in total, with maybe the most obvious one being a web application backend. When you think serverless, when you think functions, think about APIs, right? You're not going to develop a front end, normally speaking, inside a function or a web or logic app. What you would do in your function or logic app is develop that API, where you still have maybe an app service that is hosting your node or whatever type of front end that you have. And there, whenever you get a request, in this scenario, for example, there's someone order picking, he picked an order that is put on a queue. That function is triggered based on the queue, and it scales with the amount of messages. So there's no bottleneck there. Scales with the amount of messages, processes that message from the queue, puts it in Cosmos DB, and from there you can do a whole lot of other stuff towards visualization. Another beautiful example, I think, is real-time file processing, something super common on the Azure platform. A file of whatever type is created somewhere in a blob storage, and a function is automatically triggered the moment that file is created to process that. And in this case, it's a healthcare scenario where from the function we trigger our cognitive services API, do some OCR detection, and then input that data into a SQL database, all within a single function. Another beautiful example, real-time streaming. We got huge amounts of input through an event hub or maybe even an IoT hub, function again scales with that input, the amount you have. If it's slow, if it's let's say Black Friday and you get a whole bunch of events coming in, the function just scales with that, parses that. Same on the Cosmos DB side, you can scale that and then visualize your data. And last, pretty nice use case is just automation of scheduled tasks. So functions or LogicApps, for that matter, is not only reactive or trigger based or event based. You can also have it as a scheduled option where you, for example, every hour do a check, or once a day execute the function to do some cleanup, in this case of a database, for example. Right. So let's have a look at functions itself. What is an Azure function? Because we talked about it a little bit already now, but how does it look? What is it? How does it feel? Right. So a function itself is a bit of a marriage between your code and your data and events. It's a beautiful animation here that makes that beautiful logo. So a function basically marries these two. And when you look at a sample code, which we'll write in a second together, you will see that there's a request there, which is your trigger. There's an input, which is your context, and there's an output, which is your result. And all this you define in a fairly simple JSON structure where you say, okay, I have a function which is HTTP triggered inbound, which is the request. We have an HTTP outbound, which is the result, or RES. And then we have a connection to a table where we have the in variable will be our table where we can easily do manipulations on that table there. Now, from a trigger and output point of view, what is available today? Well, basically whatever you need, right? So we can, like I said earlier, we can schedule. We have HTTP, blob storage, and all kinds of events, queues, and topics that you can leverage to various services. And I think the most important one there is that when you leverage an event hub, you can essentially plug in whatever event source that you wish into that function, right? And if you can't do it through an event, well, most likely you will be able to listen for an HTTP request or a webhook and have your function triggered. From an output point of view, it integrates also neatly with practically any Azure service that you would like, where you have native support for Cosmos DB or SQL Server, where you can just directly insert there in a super easy way. That's something we'll do in the next session on functions. We'll have a look at how that works with the output bindings, how we can do some of that magic there. And then from an input point of view, of course, you can get your blob contents and whatnot from the start. Now, one of the questions I get then most of our developer customers is like, okay, but you're Microsoft, what language do you support? Functions probably only is C#, right? Or .NET. And then the answer, of course, is absolutely not. We support, we're platform agnostic from that point of view. We support many languages. We support Python, we support Java. Of course, we support our own PowerShell. We even support F# if you wish. There are, of course, some things you need to be mindful of. For Python, for example, we only support Python 3.6, 3.7, and 3.8. For PowerShell, we also don't support all versions. It's PowerShell 7 and PowerShell Core 6. And for Java, it's Java version 8 and 11, I believe, that we support. So there are some small guidelines you need to follow or you need to be mindful of, but I think they're very reasonable in a way, and they follow current most used languages and supported features. So having talked quite a lot about functions and having made you hopefully very hungry to see what a function actually is, let's go into a small demo. And let me open up my Visual Studio Code real quick here, where we can create a function. So I'm here in a brand new folder in Visual Studio Code, and I'm going to create a function. Now, how do you do that? Well, first of all, you need to have a couple plugins installed, which is the Serverless plugin and for Azure to make your life a lot easier. And from there, it's fairly easy. You click on the Azure icon. From there, we'll go to the function logo. We'll click there, put in some parameters, and get that function going. So let me show you how that goes. All right. Go to the functions part, create a function here. I'm going to create a new one project. I'm going to use C#, HTTP based. We're going to give that a nice name, which is a hello world. I'm going to call it test. We leave that as a standard. Very important one here. I hope it's big enough on the screen, but it asks here for your access rights. So in our case, we're going to make it a public function, so it's going to be anonymous. Now, the other options allow you to granularly or more granularly control who and what can access your function. So if you put it on function based, it won't be publicly available, and you'll most likely hide your function behind you will most likely use an API manager or something similar to protect your function. So here we just created the function, and when we go to our files, we see a bunch of new files have been generated here. Now, when you look at the code, and let me zoom in on that code a little bit, if my IDE allows me. Why is my control not scrolling? That's a bit too big. There we go. Should be hopefully big enough. You see, it's a fairly easy function where there are some very important things to note, right? First of all, we have the HTTP trigger here, right? That indicates our trigger, our authorization level, what kind of events we're going to react to, get and post. We can do some routing here, which for now not yet relevant. And then we have the request variable itself. Now, to generate output, we can just say here, we're going to return a new OK object, which is just going to give us a status 200 back with whatever response message we put in here. And we put some code in there to make sure that it was working. Now, earlier in the slideshow, we talked very briefly, I showed you an example of a JSON file. And so that is, let me go to search it. Why cannot? No. So essentially, the JSON file, I can see it immediately, but let's just look at it later. Essentially, the JSON file describes what we saw earlier, right? That input binding, output binding, and so on. Now that I have my hello world function, I of course want to test it. So we can just press F5 in Visual Studio Code. It's going to run, and it's going to show me in a second the output here that it's deploying, and then I will be able to browse to it on my local host and have a look at what this function is actually going to do. So when we give it a couple seconds to build and execute, then we'll be able to have a look in our browser. There we go. So our function runtime is starting, and our function is available here at this endpoint, localhost, and so on. Let me copy that here. And let's have a look in our browser here. I have my Azure portal open. Let's have a look at what that looks like, right? This HTTP trigger, let me zoom in a little bit again. Executed successfully. We can see here in our script that there's a response, that there's some interaction, but of course, pass a name on the query string. So we can add here query string name equals cloud lunch and learn. And then it nicely says, hello, cloud lunch and learn. So it's a beautiful hello world sample here. Very easy, not too complex, I would say, until now, and fairly fast, right? In just deploying, how do I deploy a simple web endpoint? Well, that was all there is. Now, once we've deployed that or tested that locally, we're going to close that. And now we want to push that to Azure. So again, from Visual Studio Code, not something you should do in production, of course, right? You want to have your pipelines, you want to commit your code, have that trigger a pipeline, and do all like your security and compliance checks on your code and whatnot. You don't normally want to deploy from a Visual Studio Code directly to Azure, but of course, here for the sake of having a demo that has a little bit of progress to it, let's just do it from here. And also just from a testing point of view, if you're a one-man developer team, might just be what is right for you. So to develop, again, we're going to go to the Azure module here. We're going to press here, deploy the function app. We're going to deploy that to our subscription. You can select the function app, or you can create a new one. Let's have a look when it gives me that option. Voila. So we can select one of the functions that I already created. Let's create a new one real quick. Let's create a function app. Let's call it Hello World We're going to make it unique, Cloud Lunch and Learn, hello world test. There we go. We confirm .NET Core 3.1, location North Europe, of course, because we're based in Ireland. And here we go. We are deploying. Now, when we look in our in the browser in the Azure portal, what you'll see here, and I hope again, let me scroll maybe in a little bit, make sure it's large enough. What we'll see here is that a function will appear fairly soon in our environment. Let's have a look at functions directly. It's going to be easier. Here we go. So here we should see a function appear the moment our deployment is done. So let's have a refresh here. I see a little hello world. Let's have a look here again. It is still deploying, phase 5 of 5. So let's have a short wait for it to deploy. All right, let's come back in a second. Let's look at the one I deployed earlier today. It's essentially exactly the same. It is just a hello world function as well. So the moment it's deployed, you can look at your function itself. In the blade on the left here, you'll see the hello world function itself that we created, right? We have only one method, hello world. And when we click through here, you can get your function URL on the top here in the bar. Now, when we copy that here, open it up, new tab, go there, we'll see exactly the same message as earlier. And here we can add again the parameter name equals, let's say Cedric. There we go. And our function on Azure is deployed and is working. Now, in the meantime, let's have a look if our originals function or new function has been deployed. There, let's work from here on out with this one. So this is the newly deployed one. We see a bunch of information, of course, on runtime version, endpoints, and so on. Operating system, very important. There's Windows and Linux support. So depending on the type of workload, you might want to switch between these two. And from the get-go, like with most Azure services, you get a bunch of metrics, logs, and insights in your application from the start, right? So you get all these goodiness. Now, some cool and important things with functions that you need to be aware of. I mean, we're going to keep it fairly short. We'll try and handle as much of the topics here in the next session more in depth. But what you can do from your function itself is you can go to the actual function, have a look at the actual integrations that are on top of this function. So in an abstract way, you can see, okay, this is triggered by HTTP and there's no outputs. So in our examples that we'll write together, if you wish, next week, if you want to code along, it's perfectly fine next week. What we're going to do here is we're also going to use output bindings where we, for example, put a Cosmos DB or a SQL Server as a backend as an output. So you'll see that as well here. So it's pretty nifty what you can already see just from the get-go. Another important part here in the deployment is the fact that you can use deployment slots, very similar to app services. So you can swap slots the moment you have your new version. You can deploy to staging. The moment that's verified and ready, you swap the slots and you could achieve zero downtime deployments. And the last one that I briefly want to hit on is your configuration itself, which allows you to configure a bunch of function-wide application variables, right? One of the first questions often developers will ask is, it's all very cool, but when I want to talk to a REST API or a service or whatever, and I need to pass on a secret, where do I configure my secrets? Where do I configure environment variables? Well, this is here. This is one of the places where you could configure these environment variables. Now, with secrets, of course, do put them in a key vault and then add your key vault link here and make sure your function managed identity has access to that. But all of that we'll have a look at in our next session, next Monday, when we talk about functions more in detail and go into the nitty-gritty, hopefully, of all of this, if we have all the time. If not, we'll do an extra session, I guess, right, for even more technically in-depth sessions. So that was it for a brief functions demo. So I hope it was a bit clear that because it was fairly fast and very brief, I would say, but the power of your functions, right, is pretty impressive. It didn't take me any time. It practically took me like 2 minutes to get the code deployed. I know it's a hello world sample. Of course, in real time, in real world, you'll need to spend some more time on on getting your code actually going. But from a deployment point of view, it was super easy, right? You just deploy it, it's there, and you get to go. So next week, much more on these functions. Our next topic for today is going to be LogicApps. Now, LogicApps, if you remember that slide from earlier where we showed the different applications or different serverless technologies next to each other, LogicApps was among there. And one of the things LogicApps had with it was that it's a visual designer comes with it. Now, it's super important to realize that me included, when I learned first about LogicApps, I was a bit like, yeah, LogicApps is for like people who can't develop, right? That's not real development. Real development is we write code, we do it the proper way. Now, when working with customers and working with LogicApps, I did have to, I must say, change my vision there. LogicApps definitely has a place in a developer's toolkit. It is not something that you're going to use for everything, but it's a great tool to have, even if it's only to quickly prototype APIs, for example. What you can do in a LogicApp in half a day, you can do way more than you could do when you had to write it from scratch in a code. And that is because of that powerful drag and drop or powerful action-based interface that the powerful designer. Another very important thing to note with LogicApps is the amount of connectors they have. And I have a very cool or very busy slide coming up a bit later on which connectors that are essentially. Now, when we look at the designer, the workflow designer itself, like I said earlier, you just kind of click together what you want to react to. In this case, right, when in Dynamics or when a record gets updated, we're going to do some transformation. We're going to do some registering. If the record requires an action, we're going to do an action. If not, we're not going to do anything. And then we're going to add it to a service bus topic where maybe a function might pick it up and do some more complex computing with. These type of interactions, if you have to write that in code, you're going to spend half a day easy. When you do this in a Logic app, I mean, you can click this together in an hour tops, right? Another argument, often people would say like, yeah, but Logic apps then our entire infrastructure as code is ruined because people create Logic apps in the portal. Again, that's not really true. Logic apps can be developed from a Visual Studio. So you have your full-on designer in your Visual Studio, you create everything, and in the backend, what is generated is a JSON that you can then commit to code. And from there, again, with your relevant CI/CD pipelines, deploy that Logic app as code to your Azure environment without even having to touch your Azure environment, which I think most of us dream about, right? That we don't really have to touch the portal much anymore, except for maybe checking some logs. So super powerful technology. And when talking about those connectors, like I said, very busy slide, but I just wanted to use this slide to highlight the amount of connectors we have. And it's not just Azure stuff, right? You have, of course, API management and storage blobs and SQL Server and so on. It's also our other services, right? From OneDrive for Business to a Dynamics FinOps to Dynamics CRM, and even our competitors, right? We support Jira interactions. You can interact with Salesforce, with all kinds of other solutions like Zendesk and so on natively, right? And the ones you can't do natively, well, we support from LogicApps HTTP and HTTPS queries. So again, if there's an API, you can probably call it from a Logic app, right? And last but not least, I think it's very important to note that LogicApps support EDI processes. So when you have today maybe still a BizTalk or something similar on premise, and you're looking at cloud to potentially transform your enterprise integration services, well, LogicApps is your logical choice there. I think might be even safe to say that LogicApps is the cloud native spiritual descendant of BizTalk with the type of integration it can do. Now, LogicApps alone is not going to replace your BizTalk. Don't come to me later on and say, oh, Cedric said we could throw out BizTalk and replace it with just LogicApps. That's not going to happen. You will need some other components for some of the other functionalities as BizTalk have, but there are some significant overlapping features that LogicApp has and BizTalk. Now again, a slide here where we just want to highlight again on how LogicApps can connect everything, right? In this one, you could put functions in the place of LogicApps, right? Because a function can trigger a function and then trigger SQL or do things in SQL, but you can do exactly the same in LogicApps. So again, if you're not super comfy with writing code from scratch, or you're still kind of on the shelf of what functions is or cloud generally speaking is concerned, have a look at LogicApps and see how fast you can automate business processes and workflows. Now, again, LogicApps, cloud native concept, but if you pay attention to many of the Microsoft presentations on general on cloud, is one of the things we like to say is that Azure is a hybrid cloud, and LogicApps again is a service that embodies that hybrid part of the cloud, where we offer an on-premise gateway where you can still connect with your on-prem SQL or your SAP type of servers and integrations. So definitely a solution that even if you have to keep certain services on-premise, you can still leverage LogicApps for your day-to-day business transformations. Okay, so again, let's jump into a brief demo. And the demo here that I would like to show you is how easy it is to create essentially a Logic app that will read tweets with a certain hashtag, which we shared earlier on today, the CLL serverless. Check in with read that tweet data, check in with a Azure Cognitive Service to get the sentiment of that tweet, and then post that value into a SQL Server database. So when I open my portal here again, let's have a look here. We can go to my LogicApps. And let's create a new one real quick, a new Logic app where we are going to do the exact same. So I'm going to put that in my CLL LogicApps group. I'm going to call it CLL Twitter Reader. I'm going to deploy that in North Europe, and let's review and create this real quick. So we have our Logic app. Now Logic apps fairly fast to deploy. So let's have a look if it does. Right, there we go. Already ready, and I immediately get dumped into or dropped into the designer. From here, what we can do is we can start with some common triggers. Just for the sake of this demo, to keep it short enough, I'm going to go with the new tweet. I'm already connected from deploying a fallback, let's say, if this doesn't go as fast as I hope, with my own account. So we are connected to Twitter. And so from here, we're going to continue. So what we're going to do here is we're going to follow a CLL serverless tweet, and we're going to do that every 3 minutes. And then as a next step, we are going to initialize let's say a variable, just to have a look at, let's initialize a variable saying sentiment or tweet sentiment. That's going to be a string. And it's going to be neutral as a start. Now, why do we need this variable? Later on, we're going to check your sentiment. It's going to be either positive, negative, or neutral, and so we need that variable to store that value. Now, from here, what we're going to do is we're going to do a text analysis, and we are going to detect the sentiment. For this, I deployed earlier already a Azure Cognitive Service, so I can just plug in with that. And we are going to add the text and the language as parameters to this function. Now, the text to analyze, again, very cool, because I just click in the field, automatically drops out what I can do. So I could use the tweet sentiment variable, which is neutral, so it's not going to do much. But I want the tweet text here as my variable. My language is, let's stick to English for now. And that is my sentiment analysis that we're going to do here. Next up, we're going to kind of check, do some logic. So we can do a control. We're going to do a condition here where if the score of my of the sentiment is greater than, I believe it was 0.7, then it is positive, or let's do 0.69, then it's positive. As of 0.7, it's positive. Then we do an action here. We're going to set the variable. Set variable. We're going to say our variable tweet sentiment is positive. If it's false, then we're going to do another check, another quick control to see if it's less than 0.3. Choose the value, the score, less than 0.3. Then if that is true, we're going to set the variable as negative. There we go. And then as a last and final step, we're going to insert that into our SQL Server, where we have a very simple insert row. We're going to put in the name of the database here. So this I pre-configured the connection, so that's why I can easily use it. I'm going to use the settings of my database. So I have a CLL serverless database. I have a table Twitter sentiment in here. And then I can add all my parameters that I would like. So all my fields within that database. As the date, I could do something with UTC, I believe. It's an expression. I can do UTC, so I get the current dates. Put that in my date value. As the Twitter user, and I will delete all of this after the demo, of course, so don't be afraid that I'm going to store your data. Everything will be nicely deleted at the end of this this session. I'm going to put the tweet text there. For example, the sentiment is going to be our variable that we initialized earlier. It was the sentiment. Why can't I find it now? What did I call it? Tweet sentiment. So it should be tweet sentiment. Maybe it's dropped in the bottom. Let's come back to that. And the sentiment type, sorry, is the tweet sentiment. Sorry, the tweet sentiment, of course, is the score. It's a decimal. That's why I couldn't find it. And that's it. That's your Logic app. Click together, I think, in less than 5 minutes. And if you run this one, let's save it real quick. If you run this one, we'll see real quick if anyone posted. Let's hope someone did make a tweet with the CLL serverless, because then we'll see in real time or semi-real time with a short delay the Logic app being triggered here. Apparently quite a few of you that have tweeted, and we'll see the process being triggered. Let me go up one and let's refresh here, and we'll should see a couple of tweets appearing in the runs. If not, let's let this keep this running. Let's rerun this again. Nothing yet. Let me go to my fallback Logic app real quick and show you how it would look if it triggers properly. We go to the CLL Twitter reader. This is going to be the one, I believe. This one has been triggered, right? So we see a bunch of triggers here as early as 6:17, so a bit earlier today. People were already tweeting. When we click on this one, we can just see what's going on here in that tweet. We see a new tweet someone has tweeted, right? Lisa tweeted with this hashtag in there. We can see that the variable was set. We went through to detect the sentiment, right? We go Lisa, go Lisa. We saw here the sentiment appears to be very positive, 99%. So we check the condition, it's true, we set it positive, and here in the end, we've set the records with the person tweeting, person tweeting, Hugo here, with the tweet text, the sentiment, and the fact that it's positive. And that, again, like I said, I mean, it took 5 minutes, maybe 10 minutes, especially when once you get used to this entire Logic app interfacing, it is super fast in how you can create interfaces and create real quick, small interactions to connect certain processes to each other. And this, I mean, from again, cost perspective, the more people tweet, the more events we will have. And let's have a look if we run this again. If we'll see some extra events popping up, 6:42, right? So we see a bunch of extra tweets appearing in the list where that are now being picked up. So again, as long as nobody would be tweeting right before the event, maybe tomorrow, not a lot of people will be tweeting with the hashtag, I won't incur any costs on this interface, which is, I mean, a great thing for when you know that there's traffic going to happen. You don't really know when, but you just want to be snappy and pick it up. Well, LogicApp might be a beautiful solution in that case, from a speed perspective to create something really fast, and also from a cost perspective, right? Again, we'll go a bit deeper on input, output, logic, and so on with LogicApps and how to integrate with some of the other applications in our next session. That will not be next week, but the week after. I have dates on the end of the PowerPoint. We'll have a look at those dates. All right. So that was LogicApps demo. Hope I showed you how to, in a very quick way, create a fairly simple or fairly straightforward integration. But if you had to do that from a code perspective, I'm pretty sure you couldn't have done that in 5 to 10 minutes, right? Even with everything ready like this SQL and so on, because that's right, kind of cheating to have everything ready and only have to do the integration part, right? One last technology that we had on our initial list of serverless technologies is the Azure Event Grid. Now, the Azure Event Grid is a bit a weird one and a bit less the focus of this Azure Serverless series, but it's nonetheless a quite important service. And you will see it pop up again a couple times in the coming sessions, because Azure Event Grid kind of is the glue or the stickiness that keeps everything together, right? It is how you manage your events, because often when you have a function and that you want to trigger on the moment Azure a file is created on Blob Store, you only want it to be triggered when a file is created, not when something's deleted or changed or anything. You want it when it's created. And so that's where often an event grid will come in, where event grid will be your management layer or your connectivity layer between everything, right? You say what kind of event you want to subscribe to, you say where you want to route it, and then you optionally filter the type of events you want. So like, for example, you only want creations, or you want to have certain things. So Event Grid really is that one-stop shop to make sure you have a reliable way of processing your events. Now here we'll see, I mean, the near real time, I think, should be taken for granted in a way, right? That's what you kind of expect from these type of services. It's near real time. It's massively scalable. You read that right. It's 10 million events per second per region. So even if you imagine you have you're the next unicorn, right? You're the next Airbnb or Uber or whatever, right? You come out of nowhere, you have to massively scale, and you're like, okay, 10,000 events, Cedric, per second. That's not enough. We need more. Well, okay, then just go multi-region solution to that problem, right? We have, I think, 50 plus regions today, a lot more than 50. I have 52 in my head, but I think it's quite a few more by now. So do 50 plus times your 10 million per second, and that's the max bandwidth in a way you can gain with Event Grid if you want to use that as your event handling unit. And last one is high reliability, right? Not only because, I mean, as an Azure native service, it has built-in reliability and SLAs. It also has that retry where you can have delivery delayed because of maybe some other outages in downstream in your event handling pipeline. Now, Azure Event Grid is a bit is one tool, or should be one tool in your tool belt for messaging, right? In the first slides, we said that you need to think about architecting your solution in a serverless context. And when we talk about architecting serverless application, we often talk about how are you going to manage events and how are you going to interconnect these different parts of your solution, of your application. And Event Grid is one amazing service for reactive eventing, right, from one Azure service to another, but it's not going to be that one tool that fits all. Generally speaking, one tool that fits all does not work. You do not eat a steak with a spoon. You use the relevant cutlery for eating a steak, and the same, you don't eat soup with a steak knife, right? So we have a couple of other services that kind of fill in those different niches. And often a question I get from customers is like, okay, Cedric, but which one should we use, right? And the answer there is always, it depends, but they're very distinct services. So first one is a very simple queue with storage queues. If you just want to have a very simple first in, first out type of queue where you don't want to bother too much about advanced things like dead lettering and the likes, have a look at storage queues. Very cheap and efficient way of queuing events and just getting them to a function, logic app, or any of the other functionalities. Service bus comes in play when you need enterprise grade messaging, right? Service bus comes with larger message sizes possible. You have lots of options to tweak how the performance works, but also you have features like dead letter queues and retries, all kinds of types of queuing methods and the like. So very fully features for enterprise messaging. And then the last in the family next to event grids is your event hubs. And event hubs is something when you have massive scaling, right? You're gathering telemetry data, you have somewhere something that generates lots of messages, lots of events, put that on an event hub. Event hub is made to scale massively and offers you that streaming interface. Think, for example, a good example of an event hub implementation is the Azure IoT Hub that's built on top of event hubs, right? So think of that massive amount of streaming that you can do with IoT devices, where Event Hub is made to handle that. The last one of our serverless options that we're going to talk about here today is Azure Container Instances. And Azure Container Instances is a bit and I have to admit, is a bit weird in this lineup, right? Where we talk about serverless functions, we talk about LogicApps, which is a bit the broader of functions, let's say, where we talk about event grid to handle those events, and then all of a sudden we have something that often would require a VM to deploy a container, right? What is serverless about it? And I think it's often a service again that is a bit underappreciated. Azure Container Instances is a crazy powerful and super feature-rich service, because what it allows you to do, and where, for example, a function lacks, is a function shouldn't be something that runs for a long time. If you have a function running for an hour or two, it's no longer going to be a cheap or efficient method of using compute. Azure Container Instances is more a match for that type of workload. Azure Container Instance is made for batch workloads, for those long-running processes, for things that you spin up temporarily and then shut down later on again. And it comes also with that micro billing of a per second billing. And the cool thing here is you can deploy a container without having to worry about deploying Kubernetes or deploying a VM with Docker on top of it. It's literally a no-hassle container deployment. Now, what is it, ACI? Well, it is running your containers from Docker if you want, without having to worry about VMs. Offers you increased agility, and if you look very closely at that middle sign there, you see the AKS logo. And what that increased agility often means is, in AKS, you're kind of limited in a way. And don't get me wrong, AKS is by far not a limited services, but you're kind of limited to the scale or the speed of how fast a new node can start up and get added to your Kubernetes cluster. So when you have high burstable compute requirements, AKS can be it can be a struggle to scale with AKS fast enough at that point in time, right? The scaling unit is also fairly big, right? Because you're going to scale with full-on nodes extra. Sometimes you just need like a quick burst of capacity, and that's where ACI can be an amazing option with AKS ACI bursting, where you can have pods in virtual kubelets on your Azure Container Instances in a couple seconds online, carrying that capacity, extending your Kubernetes cluster, and providing that compute. And the last one on the features here is your security, right, where we have full-on isolation of your container instances. Container instances themselves, look at them a little bit like you would at a Kubernetes pod, right? A container instance itself exists out of a container group, which essentially can be one or more containers sharing the same compute resources, right? You have you have flexibility in the size and the scale of your container instances, from a single vCore to multiple vCores and memory. You can all configure that on deployment. And when you use a container group with multiple containers, those containers will share those resources, will share that same life cycle, networking, memory, and so on. Even network resources, right? If you want to mount a blob or Azure files, you can mount it directly onto your containers. So it's a very nice way if you have a smaller application or some logic to run in a container instance. I think one of the most beautiful or elegant examples I've seen of container instances is people who build machine learning algorithms, right? They use Azure Machine Learning, and at the end, when they've trained their algorithm, Azure Machine Learning can generate a container. That container you can run on all kinds of different solutions. Often it's run on AKS, but for this specific use case, it was a machine learning algorithm in a container that didn't need to be running 24/7. It was kind of on demand. The customer would say like, hey, I now want my calculation, right? I now want to know what the weather is for tomorrow, for example, and that calculation would only run at that point in time when the customer requested. Now, this is a specific case where you don't necessarily have to have that container run 24/7. You need to have it run the moment your customer says, here's my input data, what is the result of the algorithm? And so what we did with this customer was we assisted them in deploying their machine learning to Azure container instances. We shut them down, and the moment the data was ready to be parsed, we used an Azure function to start up your container instance, do the processing, feed it the data, do the processing, give the result, and we shut it down again. So that brings down your compute need from having to run 24 hours a day, 7 days a week, to just run for that 1 hour where that compute needs to be done. One cool thing I forgot to mention on container instances is you can add GPUs to your container instances. So even when you have smaller workloads that require GPU parsing, and let's say you want to do some smaller rendering solutions, you could do that from a container point of view, right? You don't always have to go through an Azure batch with VMs behind it to do your rendering, or one of the other tools. So all in all, I think ACI, beautiful solution, needs a lot more love than it gets today. And let me show you a real quick demo. Again, it's going to be very simple, just a simple hello world to give you an idea how it looks, how it feels today. And then in 3 weeks from now, I think it's the 7th of December is going to be the session. We'll do a session where we go a bit more on how you can control public IPs, DNS, networking, how you do that startup from scratch through functions and the likes. So that's the goal for our next session. So let's go back to the portal, and let me show you what I've put here as preparations, right? So when I search for my Cloud Lunch and Learn groups here, I have a Cloud Lunch and Learn ACI resource group. Within a resource group, I have my fallback container instance already running, which we can have a look at if the deployment itself takes too long or might fail, right? Because we never know, the demo gods are not always with us. Another service I have here is a an Azure container register. So I just use this to use a local container or a container native to my, or an image at least native to my tenant. So I have here in my repository, I have the very simple ACI tutorial application, version 1, which I can then deploy seamlessly into my portal. So let's have a look at how we would do that. We essentially have this amazing one-liner command here. And let me share that. Can I drag this out here? Let's open this here. No. Let me share that in my Visual Studio Code real quick here. When I add a new file, test.txt, there we go. This is how the command essentially looks, right? I set my account here. That's not relevant. But this one is what we're going to do. So we're going to create a container in the resource group Cloud Lunch and Learn Serverless ACI. It's going to have the name ACI Tutorial App Test. This is the container or the image I start from. 1 CPU, 1 GB of memory. This is the registry where I'm going to log into. Username, password. You can see that now because I'm going to be delete everything, like I said, later on. So no worries there. This is not a good practice, right? You don't want to do this in a production environment. Just have your password clean in there. Please use a key vault. The port that I'm going to expose, and then I'm going to add a DNS label to it so I can publicly access this. Now, when I copy this command and I go back to my Azure portal here, there we go. Let me paste that here as plain text, and let's have a look what's going on there. When I execute that, you should see it running for, I mean, it's going to take a couple seconds to run, maybe like 30 seconds tops, and it will deploy a full-on fresh instance of my container environment here. Let's have a look if we can refresh that here. Let's scroll this down a little bit. Let's refresh again. So it's still running. Can take a couple seconds, right? It's not always instantaneous, sadly. Occasionally we have to wait a little bit for these things to deploy, but essentially it will deploy this beautiful ACI tutorial app. And when we open it up, you'll see that it already has this DNS name with it, FQDN with it, and it's just waiting for a public IP address there, and we got it. Now, if you open that, go to a new tab, put that in, we see this the beautiful ACI logo. So this is a crazy simple demo, right? This is nowhere near showing the full potential of what ACI can do, but it does show, I hope, how easy it can be to deploy a container from a machine, right? The moment you have your image somewhere published, right, and you can do that from CI/CD very easily. The moment you have it published, we're good to go, and we can just deploy that container within Azure container instances with a lot of features out of the box, right? You get some nice events, you get access to your logs, you can even connect directly into your container. Let me close this real quick here, and get a shell session within that container, right, where you can do a ps-ef, for example, and see what your processes are running. So very, very well featured, very well rounded service that you can leverage in your environment. It's definitely a tool you should keep under the belt. Now, when we look back at what we've seen here today, because we're coming towards the end of our time, I think what are some of the things I hope you've saw or learned or take away from this session is that the first one, serverless is awesome, right? I genuinely get excited when customers come to me and ask me, hey, Cedric, can you tell us more about functions? How do we use this? How do we build applications with this? That really fires me up in the morning, gets me out of bed. I think it's one of the greatest ways of leveraging cloud. It's super efficient, super fast, and very all in all, I think it's an amazing technology. So I hope at least that I managed to transfer to you. Another very important thing when talking serverless is you have to think event-driven and think limitless scale. Your application doesn't have to be, like I said, the next Uber or the next Airbnb, but it could be when you leverage serverless, right? Even if it's just an application that 5 people are going to use, serverless still is a great choice for you because, again, you pay per execution, right? Next one, I think, is serverless, great way of leveraging workflows. Sometimes you just don't have the time to build a new application from scratch, but keep serverless as something that you could leverage the moment you need to integrate some service with each other. Again, it's fast deployment, super easy to get working with, and easily to help you connect different things. And something we've said many times already now is serverless is a cheap and efficient way of leveraging Azure or cloud compute. It is, I think, by far one of the cheapest methods of leveraging compute, for sure. Compared to a classic VM, you're going to have a difficult time to make a function be more expensive than a VM that would do the same, unless you have long-running functions, because then you should have used ACI, right? One of the things I want to impart with you, which you'll also find through the link that we shared on the start, and we'll share in a second, is some of our learning paths. We have on MS Learn some really great paths and modules surrounding Azure Serverless, LogicApps, and ACI. Definitely have a look there. If you want to prepare more for next week's session, do check out the Create Service Application Learning Path. We will hit on some of the concepts seen there, some of the samples there we'll go through. But if you have time, have a look at that, and we'll definitely help you keep up or code with next week. Last but not least, I want to just real quick rehash. We have sessions coming up on functions itself, LogicApps, and container instances in the next couple of weeks. So do check in then again, and we'll go a little bit deeper on each individual technology there, where we'll go a bit farther than just a simple Hello World sample. And with that, I think I'm done. I hope this was relevant for everyone. And I'm not sure if I give the word back here to Lisa. I see you just rejoined, Lisa.
Hey, Cedric, thanks for that session. That was great.
All right.
So we don't have it, we've had a good few comments throughout the session. We don't seem to have any questions yet. Oh, Darren has just popped up. Hey, Darren. Cedric mentioned that we could code along next week. Interested in how this will work. So what would, if you
good
were...
Good question, Darren. Very good question. That is an excellent question, actually. Just make sure you have a Azure subscription where you're allowed to create resources, very important. And I will mainly use Visual Studio Code. If you check the learning path on Serverless, you might want to pre-install the Azure modules and the function extensions, if that's still relevant in the latest version. I think it might already be included nowadays. But just make sure that you can do the Hello World demo. If you can do the Hello World demo on the Azure Docs, then you're good to go to follow along next week.
Okay, brilliant. We'll catch up offline and get those links together. And then, Darren, if you want to DM the Cloud Lunch and Learn Twitter, we can work with you to make sure that you're sorted for next Monday. And you've got what you need. In terms of having an Azure subscription that you can play in, what is the best way these days to do that without perhaps spending any money? Is there a way to do that?
I think today there's still a good way to do it. If you go to azure.com, I believe, there is still a way to create a temporary free account. Also note that if you have Visual Studio licenses, right, you should normally have access to a free account that has limited credits every month. Like I think it's $150 per month. Don't pin me on that number. I don't know by heart. But if you are a Visual Studio Pro license holder, you should have through your Visual Studio portal access to Azure through credits. If not, then you can create a free subscription where again you will get a certain amount of free credits for the first until you've used them, essentially. Do note that for the free subscription, you will have to put in some credit card details. This is as a method of identifying you. And if you want to consume Azure, then your credit card past the credits, your credit card will be billed. So be a bit careful there that you don't rack up a 5K invoice. Now, we should not get anywhere near that in next week's session. Again, we're going to be working for, let's say, an hour, maybe an hour and a half on Azure. In that time, it will be very challenging to get a huge bill, and you can remove everything afterwards.
Okay, awesome. Thanks so much for that, Cedric. Really awesome.
No problem.
If anyone
Thank you very much.
Questions for next week about getting set up, please just send a DM to the Cloud Lunch and Learn Twitter account and the team will help you out. We'll do our best to make sure that you can code along with Cedric next Monday.
Perfect.
Okay, thanks so much. See you later.
Thanks.
Enjoy the rest of your day.
See you next week.
Bye-bye.
Ciao.